value of b separate, pulled out so we could actually see the value of h, or if you're following the book, well no, c is negative pi, but this is h. We could see the phase shift right there. The value of b is 2, which means that our phase shift, actually this negative pi over 2, means our phase shift is right pi over 2. Our vertical shift is up 1 from the original parent function of tangent with respect to that graph. Now to calculate our new values, we're actually going to do the reciprocal of this, so we'll do 1/2 times our x, and the opposite of this, to make it go right, we'll have to add pi over 2. But what's outside the parentheses is exactly what we do to y. 1/3 times y plus 1. So this will give us our graph. From there we can write our vertical asymptote and our all the equation for all of them. The period right now is pi divided by b, so pi over 2. So it actually is a horizontal compression of 1/2. For the parent function, the period is pi. This one, it's pi over 2, half of what it was before. So we start with our original parent function from negative pi over 2 to pi over 2. And we have the undefined values, the -1, 0, 1. Now we there is no no vertical reflection across the x-axis, or even a horizontal one, we should see the tangent the way we expect it. It's just going to be squeezed tighter for the x coordinate. And also vertically shrunk a little bit. Alright, so for our x coordinates, I have to do 1/2 times this x. That gets me negative, multiplying every denominator by 2. Negative pi over 4, negative pi over 8, 0, pi over 8, pi over 4. That's the nice thing about having them. If you've calculated the top two, you know the bottom two already. Now, I like to have these all in the same denominator, so I'm going to convert these two by multiplying top and bottom by 2. It's going to give me negative 2 pi over 8. And the other ones stay exactly as they were. They're all pi over 8 units away. These are evenly spaced. The only thing we've done so far is the 1/2 times the x. I now have to add the pi over 2, but these are all in terms of eighths. So to add pi over 2, if I multiply top and bottom by 4, I'm actually going to have to add 4 pi over 8. The equivalent, the fractional equivalent to pi over 2. This gives me 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, and 6 pi over 8. All evenly spaced. That's my final x coordinate. I did all the transformations. That's where I'm going to have to scale my axis to fit those. And because since they're all positive, I'll actually use the full right side of the graph and then just do the other period on the left side of it. For my y coordinates, I'm supposed to multiply everything by 1/3 and add 1. That does not affect my undefined values. It does affect the -1, 0, and 1. That's -1/3 plus 1 is 2/3. Or 0.6 repeated. 0 plus 1 is 1. 1 times 1/3 is 1/3 plus 1 is 1 1/3. If you want, you can write the decimal approximation to help you plot it. So I'm going to scale my graph to go up to 6/8. So I'm actually going to make it 8/8. It just makes it easier. So if that's 6 and 8, then here's 4. Wait, I'm sorry. If this is 8, this should be 4, right? Because it's halfway, sorry. That would make this 2, and halfway between 6. Got it evenly spaced. 4 pi over 8, 8 pi over 8. I'm going to put in the single units as well, just because it makes it easier for me when I go to plot. So this will give me my original, not my original, this will get me my function graphing these x coordinates and these y coordinates. So I'm going to start by plotting at 2 pi over 8, I have a vertical asymptote. At 6 pi over 8, I have a vertical asymptote for the undefined value. At 3 pi over 8, I'm supposed to go up 2/3, so not quite to 1. At 4 pi over 8, I'm supposed to go to 1. And at 5 pi over 8, I'm supposed to go up to 1 1/3. So I can still see my tangent function. Now it's up to you. If you have more room to the right and you know, hey, these are all spaced an eighth apart, I already have 1, 2, I just need a third one and then a vertical asymptote, you can do that. Or you can go to the left. I'm going to go to the left, but you could go to the right. There's 1, 2, I need a third one, but this is negative 4 pi over 8, making this negative 2 pi over 8, negative 1, and negative 3. From this vertical asymptote going left, I'm supposed to start at the value of 1 1/3 at the next tick mark over, as long as they're evenly spaced. So 1 1/3 here, then go down to 1 at the next tick mark, then go down to 2/3 at the next tick mark, and then the next tick mark is the next vertical asymptote. So I've got my graph. We were asked to find all that stuff. We already know the phase shift. We have that. The vertical shift, we have that. The period. The period's going to help me find my expression for the vertical asymptotes. As long as I know where the first positive one is. The first positive one is at 2 pi over 8, which is pi over 4. You can write it as 2 pi over 8 or pi over 4, plus a period, which is pi over 2 times n, where n's an element of the integers. Every half pi units, this thing's going to repeat. So it was at 2. There's 2, 4 pi over 8 is half pi. Every half pi units, it repeats. This concludes the notes for graphing tangent. We will be looking in our next lesson at graphing the reciprocal function.